Welcome to one and all for this today's session. In composite material structures, we are discussing micro and macro mechanics. In today's topic is bonding techniques in composite materials. In this session, we are going to talk about the bonding techniques and what are the types of bonding techniques, then advantages of bonding techniques, limitations of bonding techniques, finally the applications of the bonding techniques. In today's class, we are going to discuss these things all. So, what are the bonding techniques and what we are going to do here? In bonding techniques, actually in composite materials, it involves estimating the properties of composites by bounding the behavior of individual constituents. These techniques are used to predict the elastic, thermal, and electrical properties of composites. So bounding techniques are used to predict the elastic, thermal, and electrical properties of the composites. What are the types of bounding techniques are available? So these are very important in this topic. First one is rule of mixers. It is a simple and widely used method that estimates the composite properties by averaging the properties of individual constituents. Estimate the composite materials by averaging the properties of individual constituents like fiber and matrix individually. Then it will find bounding with the fiber plus matrix that is equal to composite. Like that, we are going to estimate the composite properties. And another technique is called Halpin-Tsai equations. It is a semi-empirical method that estimates the composite properties by considering the fiber matrix interaction. Then another one is a Hasin-Strickman bounds. It is a variational method that estimates the elastic properties of composites by bounding the behavior of individual constituents. The last technique is called Mori-Maka method. It's a mean field method. Generally, it is called a mean field method that estimates the elastic properties of composites by considering the fiber matrix interaction. Then we can go for the advantages of the bounding techniques. It's a very simple one. It's a simplicity, then efficiency and flexibility. That is, bounding techniques are relatively simple to apply and require the minimal computational effort here. In the bounding techniques, it's very simple to apply, as well as they require minimum computational effort only. Bounding techniques can provide the accurate estimates of composite properties with minimal experimental data. And bounding techniques can be applied to various types of composites, including unidirectional cross-ply woven composites. Then what are the limitations of bounding techniques? One is assumptions, what we are taking care of. Then accuracy, scalability. Bounding techniques rely on the simplifying the assumptions, such as a linear elastic behavior and perfect fiber matrix bonding. Bounding techniques may not provide accurate estimates of composite materials, especially for complex loading conditions such as complex geometry. Bounding techniques may not be applicable for large-scale composite structures also. If for a simplified composite structures only it is valuable, then it will be the limitations. These are the limitations of bounding techniques. What assumptions we have taken, like elastic property. Then accuracy also very important parameter, because for simple structures with the unloading conditions only it is accurate solution. Then large scale composite structure is not applicable for this. So bounding techniques having more limitations because of the assumptions what we have taken, as well as what are the applications we can go for that. Material selection is one application. structural analysis and design optimization. Bounding techniques can be used to estimate the properties of various composite materials and selecting the optimal material for the specific applications also. Then bounding techniques can be used to estimate the elastic properties of composites and perform the structural analysis. Next is bounding techniques can be used to optimize the design of composite structures by estimating the effects of fiber orientation and the volume fraction as well as the material properties. So applications are very important: material selection, then structural analysis, and then design optimization. These are the very important things. Then we can go for an elaborate thing. In rules of mixtures, we can have an assumption, a linear relationship between the properties of the constituents of composite materials and the composite. And it estimates the composite properties by averaging the properties of individual constituents. Simple and widely used, but can be inaccurate. This rule of mixtures can be inaccurate for complex loading conditions. As well as another equation called Hall-Pentesa equations. It is a semi-empirical method that estimates the composite materials by considering the fiber matrix interaction and accounts for the effect of fiber orientation and the volume fraction on the composite materials. As well as it is more accurate than rule of mixtures, but still relies on simplifying assumptions also. Another bounding technique called Hazen-Strickman. It is a variational method that estimates the elastic properties of composites by bounding the behavior of individual constituents, and it provides the upper and lower bounds for the composite properties, as well as it more accurate than rule of mixtures and Hall-Pentesa, but it requires more computational effort. It's the more accurate method, but it gives as well as it requires more computational effort than the Hall-Pentesa as well as rule of mixture. The another one is called Mori-Tanaka method. It's a mean field method that estimates the elastic properties of composites by considering the fiber matrix interaction. It accounts for the effect of fiber orientation as well as the volume fraction on composite materials. It is also more accurate than rule of mixtures and Hall-Pentesa, but it requires more computational effort like this has in Strickland bounds. With respect to the advantages, what we have dealt with the simplicity, efficiency, flexibility also. Bounding techniques can be used to apply for various types of composites, including unidirectional, cross-ply, and woven composites. And with respect to the limitations, bounding techniques rely on the simplified assumptions such as linear elastic behavior and perfect fiber matrix bonding. As well as bounding techniques may not provide accurate estimates of the elastic properties of the composite materials, especially for complex loading conditions. And bounding techniques may not be applicable to large-scale composite structures, as said earlier. Then application point of view, the same what we have discussed, material selection. That is, bounding techniques can be used to estimate the properties of various composite material and selecting the optimal material for specific applications also. A very important parameter to notify material selection. Then structural analysis for whether it can withstand or not. Damage failure analysis can be done. So bounding techniques can be used to estimate the elastic properties of composites and perform the structural analysis. Then design and optimization. It is also bounding techniques. It can be used to optimize the design of composite structure by estimating the effects of fiber orientation, volume fraction, and material properties. So we can discuss the mass volume fractions of fiber as well as matrix in the later. So that's all in today's session. What we have discussed is bounding techniques. So what is a bounding technique first? Then what are the techniques are used here? What are the advantages and the limitations as well as the applications? These are the things we have discussed in this class. We will have another topic in the next class. So thank you for watching this session. Thank you and all.